Alright, in this section we talk about exponential integer exponents in the quotient rule. So the first thing I want to point out to you is that when you have a negative in an exponent and it's in a fractional form, you can just cross the fraction bar with the exponent and it will flip the sign of it. Now typically you want to get rid of negative exponents, so you cross the bar with anything that's negative and makes it positive again. But if you wanted to, I don't know why you'd want to, but you could move a positive, one that has a positive exponent across the fraction bar and we'll flip it back to negative, but generally you don't want to do that. So what I usually do is show you an extreme case and show you how the exponents change as we move things around. So let's take these one at a time. X to the negative 3. That's negative, so we're going to cross the fraction bar and write it with a positive 3 on the bottom. This one's positive and it's fine the way it is, so we leave it right there. This one's negative, so we're going to cross the fraction bar and make it positive 6. Same thing here. We're going to cross the fraction bar and make it positive. Now this one's negative. We're going to move it up and make it positive 2. Here we're going to move that one up and make it y to the positive 6. This guy is already positive, so let's leave it right where it is. And this guy will move it up and make it positive. And there you go. All right. Now you would normally want to clean this up a bit. You want to combine your y's and x's and z's and w's together and simplify it as much as you can. But the point of this exercise was to show you how by moving something across the fraction bar you change the sign of the exponent. So in general, when you have something with a negative exponent, you can always write it over 1. And then you can bring that guy across the fraction bar and it makes it a positive 3. And so for that same reason, 3 to the negative 4 is 1 over 3 to the positive 4. Now you can bring an entire term of variables across the fraction bar and makes it positive 2 from negative 2. And then you hit each one with that 2 to simplify it completely. Now another way that you can look at these is when you have division of terms where the bases are the same, you're subtracting the exponent. So it's 5 minus 3, which is 2. Right. And if you got a negative in the denominator, you bring it up top and makes it positive 3. If you got two things that are negative, you can flip each one, move this one down, move that one up, and each one changes sign. Now another way you can deal with the negative and the exponent is you can take away the negative and just flip the fraction, and that makes it positive. So there's multiple ways that you can do this. You could have raised each one to the negative 2 power and then moved each one across the fraction bar, and you get the same answer either way. It doesn't matter which way you do it, but you get the same answer. Alright, so let's look at these questions here. First one, a to the negative n is 1 over a to the positive n. 4 to the negative 1 is 1 over 4 to the positive 1. You probably wouldn't need to write the 1. 1/3 to the negative 2 is 3 over 1 to the positive 2, and 3 over 1 is just 3, and 3 to the second is 9, we know that. And now here you can add all these together, just like we've done in the previous section. You add the exponents, you get negative 4, and then cross the fraction bar with it, makes it positive 4, and 3 to the 4th is just 81. And this is power to a power, so you multiply. So notice the rules are the same here, whether the numbers are negative or positive or whatever, the rules still hold. Same base you add, power to power you multiply, right? And so you change that by writing 1 over 2 to the positive 3, which is 1 over 8. 1 to the 9th is just 1, 1 to the 7th is just 1, 1 over 1 is 1. This one you can bring it up top and make it positive 3, and that's 64. Okay. Here I move the 5 to the negative 4 and the 5 to the negative 2 across the fraction bar, and each one flipped sign. And then I just did the 4 subtract 2, which is 2, and 5 to the second is 25. This one I flipped my fraction and made it positive, and now I raised each one to the second power. This one I crossed the fraction bar and made it positive 1. Same thing here with this one. On this one I added my exponents together, and then I cross the fraction bar with it to write it positive. Generally you want to write your answers with positive exponents only. Okay, adding all these guys together gives you this, and you cross the fraction bar with it. Adding my x's to give you negative 3, adding my y's to give you positive 3, and you cross the fraction bar with the x, The y does not cross the fraction bar. Notice that. Just the item with the negative is going to cross. Okay, now you can bring the entire thing down across the fraction bar and make it positive 3 and then raise each one to the 3. Here you can do 10 subtract negative 3. Remember, 10 subtract negative 3 is really 10 plus 3, or 13. And 4 and 2, you can cancel a 2 here, and you have a 2 on the top, and you can cancel one of the z's on the top with one of the z's on the bottom. You still have 3 z's left on the bottom. Here you can cancel 5 goes into 10 twice, and b to the 4 comes down, b to the 5 goes up, and so now you got 5 b's over 4 b's. So if you cancel 4 of these b's with 4 of those b's, you still have one more b left over. And 5 divides into 10 2 times, so 2b is your answer. Or you can just say 5 subtract 4 is 1, right? This is a to the third, b to the third. This one you cross the fraction bar and make it positive. Cross the fraction bar and make it positive, and 2 goes into 4 twice. Okay. ab to the negative 2 is b over a to the positive 2, and you raise each one to the second power. Okay. Something to the negative 1 is 4v over u to the positive 1. Okay. And 10 to the third is 1,000. And here we're talking about scientific notation now. Scientific notation is where you take a normal number, a number in its traditional form, and you move the decimal, which is, if there is no decimal, it's always at the very end. You move it over until the number becomes a number between 1 and 10. So you move it over here until you get to 4.5, and you count how many places you moved it. 1, 2, 3, 4. So it's times 10 to the 4. So 4.5 times 10 to the 4 is the same thing as 45,000. This is written in scientific notation. Now in your calculator, it will show 4.5 E4. It won't say 4.5 times 10 to the 4. It'll say 4.5 capital E4. When you see that E4, that's how you know the first number is your number between 1 and 10, and this is the exponent of your power of 10. Okay, and so 8 times 10 to the negative 3 is moved over, right, decimals right here, and you move it over 1, 2, 3 places, so you get 0.008. And here you're moving it over 4 places, 1, 2, 3, 4, and you get even smaller. Notice when you have a negative number for the exponent, it gets even smaller. When you have a positive exponent, it gets bigger. Okay? And so 2,000 becomes 2.0 times 10 to the third. 12 million becomes 367, 10 to the 7th, times 1.2. And move this over 1, 2, 3 places, so you get 4 times 10 to the negative 3. Move this over 1, 2, 3, 4 places, 8.95 times 10 to the negative 4. And now when you're multiplying numbers that are both in scientific notation, you multiply the numbers in front, and you multiply these two together, and when you multiply numbers that have the same base, you're going to add the exponent, so 3 and 2 gives you 5. And now you just convert that over by moving the decimal over 5 places to give you 1.5 million. So 0.3 times, or negative 3 times 5 is negative 15. These two add up to give you negative 1. And you just move the decimal over 1 place, so negative 1.5. 4 divided by 2 is 2. 10 to the 5th over 10 to the 2nd is 10 to the 3rd. And 2 times 10 to the 3rd is 2,000. Okay? And here we got some smeared ink all over ourselves here, but this is 240,000, and it's 2.4 times 10 to the 5th, because you move it over 1, 2, 3, 4, 5 places to get to 2.4. And here, 2.4 divided by 4 is 0.6. 10 to the 5th divided by 10 to the 4th is just 10 to the 1. And 10 to the 1 is just 10 times 0.6 is 6. And here they give you a huge number and ask you to write its scientific notation. So 3, 6, 9, 12, one more is 13. So 10 to the 13. And 1.246. And then for part B, they ask you to divide it by another scientific notation. So you do this guy over this guy, and it gives you that. This guy over this guy, and so you subtract the exponents, and you get that. And you're just moving the decimal over 5 places, and there's your answer. Here you're adding these together, and you get, or multiplying, and you add the exponents, and you just get 1, which is just 2. Here you're adding the exponents, you get negative 3, and you move decimal over 3 places and you get 0.001. And power to power you're going to multiply, so you get positive 8. Here you get r to the negative 2, t to the negative 6, and both are negative, so they cross the fraction bar and become positive. You can bring that guy up top and combine it with the 5 to give you 7, or you can say 5 subtract negative 2, which is really 5 plus 2 is 7. Either way you get b to the 7. This is 1 over 2, and you can cancel 2 of the x's with 2 of the x's, leaving with 5 more x's on the bottom. Okay. 3.9, you're going to move the decimal over 7 places, and you get 39 million. Here you're going to move decimal over 3, 4, 5 places, so you get 2.8 times 10 to the 5th. And they're multiplying these two together, so you multiply the numbers out in front, and you add the exponents, and then you can combine and write it as one big number, which is 20.16 trillion. And here you're going to add your exponents, and you get negative 2, which is 1 over x to the positive 2. Add your exponents, you get negative 8, which is 1 over a to the positive 8. And here you'd want to bring your a's across the fraction bar, both of them, write them as positives. Now you can cancel 2 a's here with 2 a's there, leaving it just an a on the top. 2 goes into 8 4 times, so 4a. And 2 to the 5th is 32, x to the 5th, y to the 5th, and that's as far as you can go with that.